So let's look at systematic sampling. Okay, so systematic sampling, we say that when a population is divided into subdivisions or clusters, okay, or strata, so the next question is to how to select a sample from each stratum. Okay, so in this case there is some kind of we are just referring to the one we talked about, the stratified sampling. Okay, so in a stratified sampling case, we said you divide them into some kind of groups, and then you take a sample using simple random sampling. Okay, but this systematic sampling is one of the ways that, okay, now you've been able to divide them into subpopulations. Okay, so how do you take a sample from each? Some people usually, instead of using simple random sampling, will go ahead and use systematic sampling. It works perfectly. Okay, all right. So in systematic sampling, we may number the units. Okay, you number them from population from 1 to n. Okay, so like the stats people, there are 200 stats students. You want to pick some for scholarship, and then you try to number them from 1 to 200. Okay, 1 to 200, and pick a sample. So you number them from 1, all right, 2, up to 200. Okay, up to 200. So 1 up to 200, you number them, and then you try to find, okay, now how many people do I want to select? Okay, now, okay, I want to pick a sample of, let's say 20. Let me pick a sample of 20. Okay, then you have to find your, what we call the sampling interval. Okay, sampling interval, and then the formula is n over small n. So sampling interval, you have to find k. Here k, we are saying that is equal to capital N over small n. So we call it the sampling interval. Okay, so take note, sampling interval. I'll explain why is a sampling interval shortly. So what's the capital N? Capital N is the total number of people in the population, of which this one is 200. So here your k is equal to 200 over 20. So that is going to give us, I think, a 10, isn't it? So your sampling interval here is what? 10. That means that when you pick any element, the next element you will pick will be the element that is far away from the first element by 10. Okay, so that will be the interval between the first element and the second element, the third element and the fourth element, in that order. Okay, right. So in this case, if you do that, this will be your sampling interval. So what you have to do is to look for what we call the random stats. Now that you've gotten your k, you have to look for your random stats. So your random stats will have to be done using simple random sampling. So now you go into this population with identification given to them. You can tell them to write on a sheet of paper. So the first one, write 1, 2, 3 of them, write on a sheet of paper, drop it in a bowl. Okay, so they will drop their things in a bowl, and you use simple random sampling. Okay, you are using the lottery method. So you mix them up and you pick the first element. So when you pick the first element, mostly we call that element, some people call R, the stats. So the first element, so assuming we pick the first element as the person with the number 2. Okay, it means in our sample, the first person who will be in our sample is number 2. Okay, but remember that we have found k, which k is saying that k is a sampling interval. So if I'm selecting the first person as number 2 then the second person should be 10 numbers away from 2. So it means my second person will be a 12, and then my next person will be a 22, and then my other person will be a 32. Okay, and then I'll get a 42, then I'll get a 52. All right. So the values will come depending on what you choose as your first start. Okay. All right. So this is basically what it means to do a systematic sampling. Okay, systematic sampling. So you do that, so you get the 20 people you want, and then you take them. Okay, so somebody might not choose 2, somebody will choose different number, maybe 1. They have 1, 11 in that, or somebody might even choose the 200 element. So if you choose the 200 element, then you must go back. So 200, so adding a 10 was like that will give you the 10th element. So if you choose 200, as your start, then ideally you have to go back. So we can't go forward because there's nobody forward. So we'll go back. So the next element will be a 10. Then we'll move to 20. We'll go to 30. All right. So we'll do that. So we'll get our 20 people. Okay. So this is a typical illustration of systematic random sampling. So how do you choose your pivot starts? Okay, the number that starts. So there are so many ways you can choose. So a pivot start or a pivot may be chosen in 2 different ways. So these are the various ways you can choose. So you can do that by random. Okay, the one I explained using simple random sampling, you can do that. Okay, so remember that for random sampling, simple random sampling, assuming you are using simple like I illustrated, then you have to get your complete sampling frame. Means all the 200 people should be available. That was the disadvantage of simple random sampling, so remember. And then there's another way you can choose the pivot. Okay, so the pivot is chosen at random from the individuals of the first k intervals. Okay, so this is another way you can choose your pivot. So assuming that the calculation we did, we had our k, we are talking about the second method, we had our k equal to a 10, if you remember. So the second method is saying that we can only choose elements, okay, elements in the interval from individuals of the first k intervals. Okay, so in this case we can only choose from 1, 2, up to, let's say, 10. Okay, so you remember in the simple random sample, everybody is part, the sampling frame is there, and then we use simple random lottery method to pick one as our start, and then we started generating the remaining members in the sample. Okay, but in this case, that's what we are doing. What we are doing is this: we are trying to pick a pivot, okay, from the first interval. Remember, this is the first interval. Okay, this is the first interval. So our k value is 10. So we are picking from 1 to 10. So within this interval, we will pick anybody there. Okay. So then the sample with size n would have its members. So now that you pick anybody from here, remember, if I pick a 3 as my first element, I'm calling that as my m. Okay. And remember that my 3 is only coming from the first interval, from 1 to 10. So I can't go beyond 10. I can't pick 11 in the second method. I can't pick 12. I can only pick from 1 to 10. Okay. So this is when you don't have all the members. So if all the 200 people are not around, but you still want to do systematic sampling and be able to pick a pivot, then you have to consider using the second method, that is picking from the first interval. Okay, all right. So if this is my m, then I have to get my second by adding the k. So from here, if this is 3, the next one will be 13. Okay, and then the next one I added 10 to it, 23. Okay, I do that till I get all my members, all the 20 people I want. Okay, so this is the second method. All right, so that ends these are our explanation. The advantages. Okay, advantages. So advantages are there, so this one you can read them. Okay, the advantages are there. We see that systematic sampling has great advantage of simplicity in design. So it is easy to select the kth item from a list. So if you have the list, then it is easy to select. So it is easy. It's more efficient than simple random sampling. Okay, so if provided the sampling frame is not arranged wholly at random. Okay, so even if you don't have the whole sampling frame, you can still do systematic sampling. But for simple random sampling, you can't do that. So it is more efficient when you have that. So systematic sampling will yield better results than simple random sampling, which probably it has been explained if the units within the same sample are heterogeneous. Okay, all right. Less cost. Remember that simple random sampling is very appropriate for homogeneous. So the farther there is heterogeneous, any other better method will be better than simple random sampling. And there is less cost, all right, and time. Right. So the disadvantage is there. All right. So in systematic sampling, units selected are not independent. Okay, remember they are not independent because they all depend on the first sampling unit selected. So you remember when we're doing it, you use simple random sampling. The first item you select will determine which people will be part of the sample. Okay, so if we are there and then we know I know I'm number 10 and then the k is 10. Okay, I'm number 10 and the k is 10. And then you select the first element. Now I know that I'll be part. So there is that. It's not independent. All right, so that is that for systematic sampling. Okay, so we'll look at cluster sampling.